welcome to tutorial number 20 of our series, where I'm going to show you how to simulate swarms by using Grasshopper's plugin Boids, which you can download from Food for Rhino, and also Anemone, which is also available on the same website. We will start off with something that I've done in our previous tutorial number 19, this form right here, which is just basically just a poly surface. And we also have a few things left here from tutorial number 19, so I'll just get rid of them. All I care about is just this single poly surface. Right, so just going through this to repeat what we've done, I just created a bunch of rectangles, rectangular surfaces, moved their control points around and ended up with this shape. So now in Grasshopper, I will be referencing it in, and I will just create a mesh, a smooth mesh from this underlying topology of a poly surface. So I've referenced it in as a brep, and I have hidden the poly surface in my Rhino viewport. So this is going to be a repetition from our previous tutorial, but I'll just do it really quickly. If you want a more in-depth explanation of what's going on, just look at that tutorial. Again, tutorial number 19. So I'll just deconstruct the brep. I will get its faces as separate surfaces. Let me just do that real quick. And those I will mesh those surfaces by using Mesh Surface tool. And this time around, I will just give it one division in U and V, along U and V values. So it just creates a single mesh face for every surface. And I will join them up by using Combine and Clean tool, which is native to Kangaroo 2, which I think it ships now together with Rhino and Grasshopper. There are some shading issues here, so I'll just clean them up by using Mesh Unify Normals tool, like this. And now the shading issues are gone, and we end up with a pretty decent mesh topology. So now to smooth it out, I will just use Catmull-Clark subdivision, like that, hide that, and I'll just give it level 3. Or actually, we probably just need to do that, just a panel with a number 3 in it, just to keep it small. So now we end up with this smooth shape right here, and I'll just create a preview, a custom preview, give it a color. White is not that great for a preview. Let me make it blue, and perhaps it's a little bit transparent like that. Okay, so we have our smooth shape here, and that was easy as long as we have pretty nice topology. The next thing to do is to actually start working with swarms, right? So a swarm is basically a bunch of points that are floating about in space, right? So we need to somehow create a bunch of points on this mesh. To do that, I will just create a node that's called populate geometry, which will populate the surface of my mesh with any amount of points that I want. So I just connect my smoothed mesh to my geometry input here, and I will just choose, let's say, 1,000 points. We'll start with 1,000, maybe we'll increase it a bit more later. So we have 1,000 points here. There are other things to input here, for instance, seed or existing points, pre-existing points, but we don't care about those things. All we care about is just this. All we care about is just adding 1,000 points to our surface with any random seed. And actually, I don't want the swarm of these, let's call them bees, of these bees, to start off everywhere on the mesh. I just want them to start on a certain portion of the mesh and then kind of wiggle around and then fly around this form here. So to do that, I will maybe in Rhino I will create a sphere. Let me go to top view. I will create a sphere perhaps here, somewhere here, like that. I'll just move it up so that a few points are inside of it, right? And what I want to control with this sphere, and let me change this to wireframe view. What I want to control with this sphere is I want to say that all of the points that I care about are inside of the sphere, and as I move it, I can choose which points I keep and which points I delete, right? So I will create a node that's called point in brep. In this case, it's a single brep, so point in brep. It asks me for a brep for inclusion test, so that's going to be my sphere. Keep in mind that this only works with stuff that is closed, right? And the sphere is closed. So I'll reference it in as a brep, set 1, just like that. No, let's just hide the Grasshopper preview of the sphere. And now for the points, point for inclusion test, well, it's actually these points, right? We're going to be asking, are they or are they not inside of the sphere? So that's our points. And this third input is asking if the inclusion test is strict or not, meaning what happens if the point is right on the edge of the sphere. We don't care, right? We just leave it as a default. All right. So we have our answers here as an output, basically yes or no answers. And by using those answers, we can cull, by using cull pattern, we can remove from this large point list, like that, we can remove all of the points that are outside of the sphere by just using the answers, is it in or out, by using them as a pattern, right, as a culling pattern. So now if I hide everything here, you can see that only the points that are inside of the sphere are being left. Perfect. Okay, so now we want them to behave like a swarm, right? To do that, we will need Anemone. And Anemone has these two loop start, loop end inputs, and it seems like I'm using it for every tutorial these days, so I will not be explaining what it does and how it works. If you're interested in that, if you don't know, then just check out tutorial number 19, for instance, or tutorial number 18, doesn't matter which one. Right, so let's say 200 repetitions, like that, button, like that, and these points are going to be looped, and they're going to be moved, like that, and they're going to loop around. Very simple loop that is created right now. If I hit the play button, you can see the points are just flying up. That's because our movement vector by default is set to be 10, right? So it's every time the loop kind of loops, the points are being moved up by 10 units. I will be disabling preview of all of this, and I will start messing around with the Boids library, because right now, the points are moving up. Yay, hurrah. But we actually want the points to kind of behave like swarms, right? That's what we're here for. So I'll go to Boids library or plugin tab, and under legacy, or that's actually the only sub tab that we have, I will have a few options to choose from for behavior of these points as they are moving. So a flock, or rather a swarm, always has these kind of three main rules that it needs to follow. Every bee in a swarm will try to stay close to a flock center, right? So adhere to the flock center, this one. Also, every bee will try to align itself with other bees, meaning that if all of the bees are flying to the left, that single bee, seeing that all of the bees are flying to the left, will also try and steer itself to the left, right? So align to flock members. That's the second one. And third one is repulse from the flock, meaning that if it's too crowded, the bees will try and kind of do social distancing from each other, right? So this is social distancing node right here, repulse from the flock. Okay, we have these three here. Actually, as I was talking, I was wondering, what is this? Find agents from flock visible to current agent. What does this do? We don't care. We don't care about that one. Okay, so we have three nodes here. With these three nodes, we can simulate a simple swarm. So let's start plugging things in, right? Because they need a bunch of inputs. Let's start off with this all bees trying to go to the center of the flock or of the swarm. So first input is agent location point. That's perfect. We have all of our points right here in the loop start output. That was easy. Second one is location points of the flock as a list, right? So it's basically this is what kind of points are searching for their neighbors, and this is the neighborhood, right? So it's basically the same thing, because every bee is looking at every other bee, right? So we just kind of reuse the same input. Third input here is search distance, and if 0, it's infinity, meaning that if we give it 0, a bee will see a flock even if it's like a kilometer away, and it will try to get close to it. In this case, I believe this is... we will adjust it later. So for now, I'm just leaving this empty. Then we have a number of closest agents to calculate the flock center. If it's -1, it's all. We will also be adjusting this later. And third one is, last one rather, is the multiplier. Also adjust later. For now, I just need these inputs to not be orange, right? Just to work. All right, we'll deal with alignment later. Repulsion. Let's do repulsion now. So social distancing node, right? Also asks us for points and for points here. Easy. We'll just do this, right? Same thing. They will try to get close, but not too close, basically. And last one, and I will talk about other two inputs here as well later. Last one here is vectors, right, for alignment. So for this to work, we need to know what kind of direction are the bees flying in for them to align. And to do that, we actually need to add one more input to loop start and one more input to loop end. And we can do that by zooming in and clicking this plus sign here, insert parameter, like that. This starts freaking out immediately because right now we have two inputs and two outputs here and only one output here or input here. So I'll add it here as well. Now it's not freaking out that much, but still freaking out quite a bit. But if I hit reset, it's going to be kind of okay. For clarity purposes, I should probably rename these. So let me rename B position, B starting position. So this is from where do they start flying. And this is going to be B starting direction. So they need to, kind of have a starting direction towards where they're going to fly. And then here we have B position, because this one will keep being updated, and B direction. So that's a vector, right? And same thing here. Or actually, I'll just leave this here. You get the idea, right? So for B starting direction, basically I just need a bunch of vectors, right? For this to start working. And thankfully, Boid library has this really nice random vector tool, random vector, where it basically generates as many random vectors as we need, random directions as we need. And that's just going to be for the first part of the loop, right? It's going to be overwritten by the swarm behavior for the second iteration and so on. So it's okay that they're random. Let's see at the inputs here. Number of random vectors. Well, number of random vectors is basically how many B's we have, right? So I'll just say how do we? I will just say give me the list length. Oops, that's not the list length. List length. Give me the list length of all of the B starting positions, all of these points, and we get the answer 130. So I'll just plug it in. So now we generate 130 vectors here, right? We also have a few options here. The only one that I care about is unitizing. So basically making all vectors be 1 unit long. I think that is important. So I'll just toggle true. Just to kind of know that we are starting with 1 unit vectors. And I'll just connect them like so, right? Let me group this and call this generate random directions. There we go. All right, so now we have our vectors that come in here, and then that means they come out here, B direction, right? For alignment, it's the same thing as B position for adhere and repulse, only that for alignment we do the same thing with vectors, like that and like that. Easy. And we get our vector output. Okay. So now we have 3 behaviors which generate a list of vectors. How do we work with this? The answer is we just add the vectors up, right? Addition. I will add the adhere vector with the repulse vector, and to add the align vector, I just need to zoom in and click on this insert parameter sign to add the 3rd input, like so. So now we have a vector. And actually I can just kind of show you how it works by doing this and that. It's not fantastic, right? They kind of just go clump together and they don't do much, right? And that's because they don't have any, any incentive to waddle around, so they just find, you know, the closest point, and they just kind of clump to that closest point. Kind of boring, but expected. To make them not do that, we can start messing around with these values, with adhere, repulse, and align values. But before that, let me actually disconnect it, like so. Before we do that, I believe we need to... What do we do first? Yeah, let's create some sort of a force, a driving force, wind, for instance, right? So for wind force, I want to be able to control it right with one slider, right in freaking Grasshopper. So I'll create a vector, vector XYZ. So create a vector from XYZ components, and I will say that the angle of the wind needs to be 45 degrees to all axes, which means that if we just simply give, like, let's say something weak, 0.1 to X, Y, and Z, like that, we will get... Vectors are not displayed in Rhino or in Grasshopper by default, so I need to do vector display X, point vector, zoom in here, and there it is, right? So that's our wind direction. I know it's not much, but or actually vector display. Can we just do that? Yeah, that's fine. So first of all, very, very small. I want this vector to be, you know, bigger, because if I zoom out, I can't really see what the heck is going on. So I will do amplitude, and I'll just change the vector's amplitude to, let's say, 10. And then connect the enlarged version of the vector. Oops. Connect the enlarged version of the vector to the vector display. So the original vector is here. This is just an enlarged version of it. Let me do it like that to make it a bit more compact. So we have something like this going on. Okay, that's our wind direction, right? But what if I want to control it? And also, wind blowing at that angle is kind of weird, so I'll just do negative for all of these values. X, Y, Z. There we go. So now wind is going to blow the other way around. And I want to control the direction of the wind, so I will just create a rotation, rotate vector around an axis. So I'll just rotate this vector, and I will rotate it around what's this axis right here, which I believe is, yes, X is X. I'll rotate it, nope, that's not X, around X, unit X, right? Around this axis here. And I will give it an angle somewhere between 0 and 360. Right? Connect it like so, and I will reconnect all of the, you know, instead of this one to my vector display and amplitude, I will reconnect the rotated vector to here and here. Now if I turn that, what the hell? What's going on here? It's way too fast. Huh. Oh, right. All of the angles in Grasshopper are in radians, they're not in degrees. So I'll right click on the angle input of my vector rotate and choose degrees rather than radians. So now if I change the angle, you can see, you know, I can control the direction of the wind with the slider. That's perfect, that's all I needed. Okay, so let me just group this up, and I will call this wind. Okay. And actually create a vector component and have it somewhere here. Add to group. There we go. So that I always connect the winds, you know, from the correct one, not from the amplitude, because this one is just for preview. All right. So now we have a bunch of these points, and as you saw before, they just clump together into one ball. We want this wind to blow these points to a direction. So how do we deal with it? Well, we could kind of just straight up connect that vector in like so, and just, you know, call it a day, I think. But I'm not sure if that's gonna work, because here we only have one vector and we need more than one, right? So how do we do that? Perhaps we just add. What if we add them like so? 99985. I'm just sorry, I'm just looking at the values and trying to see if this single vector is added to all other vectors, and it seems it is, which is perfect. Which means we can just straight up do this. So first, all of this steering is kind of calculated, and let me create a group for this and call this swarm behavior. And we get a vector here as an output, and then we get the wind vector as an output, and we just add them up here. So now, technically, if we reset, they should kind of, yeah, that's good. So now they're flying, right? And I can kind of change the angle. Come back. Change the angle, and they're flying in different. God damn it! Let's try again. Fly. You know, and I can kind of start messing around with angles and so on, and have them fly in different directions. Okay, that's good. So we have, you know, at least a little bit of dynamics, but that's not enough, right? We do have this form, underlying form, for a reason, and that is to not let the points leave the form, right? To make them fly around the form on the surface of our thing here, of our mesh. So just as we did in the previous tutorial, we'll do the same thing here. I will use mesh closest point, mesh CP, mesh closest point, and I will say that from these moved points, always find a closest point on a mesh. And our mesh is the Catmull-Clark mesh right here, right? So I'll just do this kind of long wire here and connect it. And then you can see these points will always snap to the mesh, meaning that they will always follow the mesh. And now if I hit reset, you can see these points are clumping together. Let me do that again. And actually let me disable the previous starting positions. So they're always clumping together. But now on the surface of the mesh, meaning that there's some interesting stuff going on here. All right. We have it working. Now let's draw some lines with it and then start calibrating stuff. So first things first is flip matrix. Again, I've explained what flip matrix does so many times that if you're interested in it, I really suggest that you watch previous videos that I've done, and you will notice that I constantly use this flip matrix node, and I explain it through and through. So I will just flip matrix of this data tree, and I will create a polyline, I guess. Polyline through these points, which means that now if I hit reset and start running the simulation, nothing happens. Why? Oh, that's because we are not recording, right? That's because only, one set of points is constantly moving, right? So we need to create a series of points. We need to record every step of our loop. And to do that, I will just right-click on the loop output, loop end, on this node here, and I'll choose record data, like that. And now if I hit reset, now all of the points are being recorded, like that. Let me disable preview of the points, just so that we only see the curves here. Okay, so they are following our form quite well. Now we will start balancing it out, right? Because we need to be able to kind of control how everything moves. I will increase the repetitions to like 400 or something close to it. Hit reset, and I'll just see how much does the wind influence it. So if I change the angle, and now I change it back, yeah, okay, I can move the swarm around my form as I please, which is good. Change it up, and it changes up. Okay, but the problem is that all of it just kind of clumps together, which is rather boring. So let me decrease the repetitions to something 137, that seems fine, and start messing around with adhere, repulse, and align calibration inputs. So for adhere, it's search distance for getting close to the center of the flock. So every bee will look at only at the neighbors that are within range to it. So I'll say that the range is, let's say, 5, I don't know, some number. I'll try 5 because it's right in the middle between 0 and 10. So try again. That's with range of 5. And now we get some more interesting results, I guess. Not really. And this is where swarms, I'm now trying with 4. This is where swarms become a little bit tedious, a little bit, wouldn't say boring, but yeah, tedious for sure. I want to be able to control how fast these points move, but just from the swarm behavior, because I can control the strength of the wind by just changing this value here. But with the swarm behavior, I don't really have a way of how to control it, except for multiplier. No, I'll do that the old-fashioned way by just multiplying everything, multiplying everything here by some value. So let's try somewhere between 1 and 5.0, like that. I'll just connect it, instead of the original one, I'll connect the multiplied one. Increase it to, let's say, 3.2, run it again. I think it's going faster, hard to tell. No, it's definitely going faster. Can we go even faster? 5? Yes, we can. Okay, so that's how we control the multiplier of this one. I wonder if we should add some sort of a trimming, because there is a way of how to check if the speed or the vector is too long, and just trim it to a certain length. Maybe nah. That would just convolute things even more. Instead, let's mess around with search distance. So if search distance is 2, we end up with something like this. If search distance is 8, everything just kind of clumps together like that, and immediately, like really quickly, jumps. So I don't like that jumping, so I will indeed be changing, like trimming using trim vector to kind of not have these really quick turns and bends. So I'll be trimming these vectors, and I'll say that the length domain so my domain will be between, let's say, the slowest movement for a point should be 0.1 to largest movement of the point should never exceed, let's say, 1.5, something like that, and connect it here like so. Let's try again. That is really fast. So let's get rid of this multiplication and straight up just connect trim vector to my outputs here and try again. Okay, that seems to do the trick quite well. And everything is kind of flowing about. Okay, that's good. I will say that 1/4 of my spaceship or my form will create the starting points for my swarm, and I will say I want more points, so let's say twice as many, 2000 points here, like that. Then, so we have something like this going on. Then search distance. What if we change this down to 3? How do they behave then? A little bit wobbly, but that's okay. But they don't clamp together. And I want them to clamp together, so I'll change this to 4. Kind of change up the angle a bit, because I'm bored of that angle here. That's 4, maybe 5, 6. So this is like the rest of the tutorial is just going to be me calibrating the swarm so that it works as I want it to work. That's like 90% of working with swarms, right? Okay, so it does that here. What about this input, reference agents count, number of closest agents to calculate the flock center. What if we say only calculate according to 10 closest agents? What will that do? Yeah, we get more clustering. Okay, that's good. What if we say 20? Even more clustering. Okay, but that's we're getting somewhere with this. So I will leave this at 20. So every bee only looks at 20 closest bees to calculate where it should go. And also it searches within 8 units from itself. And then here we have multiplier for the strength, which is, I think, fine, 0.1. Output vector length multiplier, optimal values around 0.1, so we'll leave it as optimal. Then we have repulsion. So repulsion is, again, social distancing, meaning that we can say, what if we say repulsion is 10? Something stupid. Yeah, all of the bees are trying to kind of clump away from each other and are failing. But if we then say that repulsion multiplier is less than the adhere multiplier, something like 0.05, like twice as 2 times weaker, we end up with something like this, which I think is kind of cool. And can we make this smaller? I'm just trying to kind of find correct values, and you will need to as well if you want to work with swarms. So that's how 4 works. Kind of okay. But I preferred 10 actually. So I'll keep it as 10. And then alignment is, it doesn't have any input, so that's fine. Okay, so we are getting there with this swarm, with these patterns. Let me have it run for a while, for a bit longer. So you can see they're clustering together with like 20 points, swarms of 20 points. If we want less, we can do less. Swarms of 12 points. Just like that. Okay. And now the cool part, which I think it's going to be cool, we will see, is changing the direction of the wind as the simulation is running, right? So right now the wind direction is controlled through this rotation, and here every step increases this counter output, right? Meaning that if we connect or actually I can show you here. Imagine that this counter output, this number that is going to start changing, is the angle of the wind, right? That means if I connect this loop, or rather this C output, counter output, to my vector rotation right here. Oops, I want to show it. Yeah, there we go. As the loop is running, the vector will be spinning, right? Like so. Which means that technically these worms should be able to kind of spiralize a bit more around the form. Okay, that's cool. One thing that I noticed is that the vector right now is at 45 degrees, which makes all of them move horizontally quite a bit. And I want to control how much do they move horizontally as they're doing the spiral. So I will change the Z component of the wind to just a slider that I can control independently. So 0.1 from 0.1 to 0.5. I guess. We'll see. I'll just connect it like so. All right, let's immediately do 0.5 so you can see how horizontal this thing becomes. Run it again. And it's still quite horizontal. Wonder why is that? No, now it changes. But they really move really quickly horizontally, which is strange. Like at the start. I believe that's alignment. That alignment is too strong. So let's do 0.075 for alignment. That all of them are basically, when we are aligning, all of them just catch the angle quite quickly, and all of them align to the same direction. So if we decrease the alignment, it's still kind of, oh, but it's better now. It's definitely better now. Okay, we're getting there. What if for angle we multiply, you know, here it's just counting 1, 2, 3, 4, 5, blah, blah, blah. You know, the counter is just counting like that. And we convert it to 1 degree, 2 degrees, 3 degrees, and blah, blah, blah of rotation. But what if we multiply that counter input by, I don't know, 1.5? It's just going to rotate faster, right? So if I just do that, hit reset, now it rotates faster, and I can make it rotate even faster. Does it rotate faster? Seems like it does. Wait, 10 times. Oh yeah, that's for sure. So now, now we can do a zebra. Let's not do a zebra, though. So definitely not 10, but something like 2.5, I think is gonna be quite a sweet spot. And maybe even less value here, like 0.05. Let me reset. Come on, go up. There we go. And then, as we're playing around, I can just say, I can just kind of increase it to reference, not to reference, but rather to catch 100 points by the end of the simulation, right? Okay. So now, when we have wrapped this whole thing around in swarms, we can make a mesh from them, right? So this is our polylines, and I will just right-click and flatten them to one output, 400 of them. And I will also be using just straight up, where is it? Dendro, convert. I'll just be using Dendro plugin, where I will be using curve to volume tool to convert these polylines to a volume. And the radius, I will say 0.1 for the radius. And settings, yeah, I do need settings, so I'll create the settings here. And it's freaking out. And it's orange because in my settings, the voxel size is set to be 1, but actually it needs to be smaller. So 0.05, it needs to be smaller than this curve radius. So I'll just use a half of it. And it's going to be a heavy boy, right? So it's going to take a while to calculate. But eventually we end up with something like this, right? For our shape, which I kind of like. For some reason it disappeared, but now it's back. And now I'll just convert this volume to a mesh, like that, with the same settings, like that. Let me hide the preview of these and just check what kind of output we get. And we get an invalid mesh output, which sucks, but I believe we can just use combine and clean, like that, which also takes a while. But from combine and clean, the output is going to be a clean mesh, and it's a 1.2 million polygon mesh. I'll create a custom preview. Swatch, choose a color for it. Let's say that's a boring one. Perhaps something like that. Let's go back here and increase the alpha. And we end up with something like this. So that's our swarms wrapping around the geometry. If we want to have a little bit more control, actually, now if I hit reset, it would just crash because it would calculate this whole thing, which I might as well group up and call curve to mesh, and just create a data dam here just to be safe, like that. So that every time when I kind of want to see how a mesh would look like, I will need to click this data dam. Okay, but for now we have the polylines. Oh, by the way, the polyline is freaking out a little bit because there were some zero length points there, but we don't care about it. Okay, the wind is fine. Maybe it's a little bit too drastic. Maybe this value is a bit too small. I'll turn it back to 1. And for rotation, I will turn this down a bit to like 2. So 0.1, 0.5, and 2. Again, it's all about calibration when dealing with swarms. So we have that. Then we have the points here, and at here, direction right now is not direction, but distance is 8, and reference agents count is 100. I believe, what happens if we delete the distance and run it again? Nothing, because why? Insufficient points for a polyline, a bunch of nulls. Why? Oh, that's because repetitions is set to 0. So 61 repetitions. Yeah, okay. if we just say give me 100 points, it's going to kind of create these kind of large clumps of points, which is cool, but that's maybe not what we want. I'll just say like 39 or 40, try again, see how that works. It's kind of cool. Maybe this one is just a tiny bit smaller, 0.08. 39 points again. Okay, keep going. I want to see how it's gonna end up. So like that, huh? And now it should be going the other way around. Just like that, perfect. And they are starting to connect and find each other, which is super nice. And let's do 100 points. Okay. This is also cool, right? So we can get away with a bunch of cool stuff, and a bunch of different variations. I'm just trying with a smaller surge distance and a smaller agents count. Let's say 13. Yeah, that's nice. And then we can say bump it up to 100 for the grand finale, so that all of them, you can see how they are merging here into bigger streams of points. I'll just increase the surge distance as well. Go further. Perfect. Okay, let me just give it a... there we go. Now it stopped, and I will call this a day. So that's how you do swarms on a surface with slight control. You know, we do have a little bit control over it, but it's still a bunch of bees, so it's very hard to work with these forms. But at least, you know, now you'll see how you can manage the chaotic behavior, not completely control it, but perhaps at least manage it, right? Let's bake this out like that. Invalid object, huh? Even after all of this, it's an invalid object. Man, what if we know clean tree? What if we do that? Play. I'm just now trying to figure out how to not have it as an invalid object. We'll see. Come on, stop doing that. Invalid mesh. Yikes. Why? 0.07. What if we increase the voxel size? Now it's completely broken. It's completely broken because of this one, actually. So 0.04 decrease the voxel size even further. Come on. Okay. It did something. Are you valid? You're invalid. Okay. Should I just render it out as it is? Let's fix it. Okay, so from time to time Dendro will throw this kind of a error here, and I believe it's something that we can definitely work around. There are different ways of how to troubleshoot it. First one is just grabbing list item and seeing will it work with one form, and it seems to be doing the trick. So one form works perfectly. Okay, then if one works, then I will not be using list item, but actually I'll be using split list here, connecting my polyline output to my split list input, connecting this one here, and just creating a slider between 0 and 200, let's say. And I'll be, I have 398 polylines here, so I will just be adding or splitting that list at some value, and I'll just see where it breaks. 38 is fine. What about 100? $100 is fine. Okay, what about 200? If 200 is going to be fine, I'll leave it as it is with 200. But in reality, if you really want to have, exactly that particular form from those particular curves, then you would need to rebuild these polylines. And I really don't want to do that because I like how it looks as it is. So I'll be keeping them as they are. Let me disable preview of this, of all of this actually. Just take a look at it. Yeah, I think that looks super. So we'll call it a day. I hope you learned something new and enjoyed this. I will be setting up the render for the thumbnail now. I'll speed it up as per usual. Yeah. Next up, we will have a few tutorials with more for two-dimensional graphic design, aimed towards two-dimensional graphic design, which I am sure some of you will find quite useful and quite nice. That's it for now. Thanks for watching, and I will see you guys next time. Bye.